All right. So, in review, I'm giving you what kind of a situation here? Side, side, side. And on a side, side, side situation, where would you initially go to begin this problem? Law of cosines. And you have three law of cosines that solve for three different angles. So, what would you likely end up doing here first?
C.
Now, why do you say C?
Because it's the biggest angle. It would have the biggest
Okay, so she's noticing it's the biggest angle. Why is there an advantage of finding C first?
So you don't mess it up if you do the lower side.
Okay, because we said, what she's saying is, we said that if we plan on going from law of cosines back to law of sines, there is a situation where we get in trouble. And that situation is whenever we're using law of sines to find the biggest angle, there's a chance that biggest angle could be obtuse, right? Because triangles sometimes have one obtuse angle. Sometimes they don't, sometimes they do. And if I am finding an obtuse angle, which is bigger than 90, inverse sine can't give me that, can it? Are you with me? Now, is this so what it's going to give me is the acute angle. Now, how do I know if the acute angle is right or not right? And the answer is, I won't. Sometimes I could go back and look at the work and maybe it won't make sense, but I'm better than that when it comes to a test question. So for instance, maybe angle C is like 95 degrees. Maybe it's 85 degrees. Even an accurate picture drawn by you or me is probably not going to be that detailed where I would notice the difference, right? 95, 85, it's such a small difference. So I'm avoiding future trouble by finding that biggest angle first with law of cosines, because law of cosines is like a nice golden retriever, right? It's kind to you, it never lies. Doesn't matter what you do to it, it's always going to give you back good information. But if I'm planning on going back and using law of sines, now I'm in a favorable situation because I'm finding what? With law of sines. Not the biggest angle, and law of inverse sines is like a nice cat when you're finding smaller angles. It's like a nasty cat when you're finding big ones, because you don't know how it's going to give you stuff. Now, what else could you do rather than find law of cosines with this? You can just stick with law of cosines the whole time, right? Because if I start in a situation that requires law of cosines, then law of cosines I can finish with. So I could just say, I'm just going to use law of cosines the whole time. It's not like it's that much extra effort. It's a couple extra button pushes. Are you with me? But look what happens if I actually, and even if I don't pay attention, and I go, oh, let's find B first. Which I wouldn't. I would do like Haley said, and I would find angle C first using the C squared equation. But if I use the B squared equation, check it out. Is that how I set it up? Angle B, side A and C, side A and C. And then what math am I going to type in my calculator? I'm going to type in a fraction, and I know this ahead of time. I'm going to be subtracting a 6 squared from that. I'm going to be subtracting a 12 squared. And when all of that is now on the left, I'm going to divide that away. Are y'all seeing that algebra? So I could type in a fraction that looks like this. This would find the cosine of the angle B. And then once I get that, I can do what? I can do inverse cosine, and I will get my angle B. So make sure you know how to use your calculator, but I'm pretty sure everybody knows how to do a fraction button. So fraction button, 7 squared. And don't do stuff like, oh, I know that's 49, that's 36, and that's 144, because maybe you accidentally are wrong. There's no point in trying to do extra stuff in your head. It's just as hard to type 49 almost as it is to go 7 squared. Still 2 button pushes, right? Minus 6 squared minus 12 squared in the numerator, come down. Negative 2 times 6 times 12 in the denominator. That gives me 0.909. And by the way, you could do all of this in one step. But do not round. Like I could just type in inverse cosine, big parentheses, fraction button, then it would just knock it out at once, and you wouldn't even have this step. But if I do show that step, inverse trig function of the answer, and I get 24.53 degrees. Now, assuming I did that, and then I go back to use law of cosines, look what I have now. Back to use law of sines. And this is very common. When I go back to use law of sines now, time. When I go back, I'm going to be using what situation? What information will I be using to find C? Clearly, I'll have to have this in there, right? So maybe I go sine C over, and I'm not going to do this, but I'm just showing you. And then I don't have angle A to go with that, but I do have angle B now. Sine of 24.53 over 7. But look, I'm finding an angle that goes with the biggest side. Now that doesn't make this suddenly an ambiguous case. It's a side, side, side. There's only one triangle with side, side, side. But the problem is, my calculator's forced to lie to me here, unless it happens to be acute. And I don't think this one's acute, because it's so much bigger than this. Are y'all seeing this? So my calculator's gonna spit out an answer for that that's wrong. And you're not gonna know it's wrong. And even if you do go, oh, well, it's not the answer, I'm gonna go 180 minus that answer to get the other big one. You still don't know that it's the big one. You don't know whether it's the acute or the obtuse version on a side-side angle. But it's not both, right? Is there any way to get two triangles if you have three sides like that? 6, 7, 12. There's no options, right? There's only one triangle. So what could you do here if you've already done this, and then you go, oh crap, I'm finding the biggest angle. He told me never to do that unless I had to. What could I do? Rather than go back, I can find A. Now you're like, but you didn't ask for A. So what? Right? I can still say sine of A over 6, find angle A, and even though I don't need it, how can I find angle C at the end? Yeah, 180 minus the B and the A that I just found. So you could still bail yourself out at that point, but you have to know to do that. Are you seeing that? But, like Haley said, you could avoid all this trouble if you just found C first. Because then when I go back to do law of sines, B is not the biggest angle. So you're not worried about it, right? That's nice, kid. Are you with me? Okay. All right, and are y'all sure you're good? That's a very common mistake people make. Oh, what about this? Another mistake I get is angle now this can't even be a triangle. Why? Because this, if this goes with A, if B is bigger than A, then angle B would have to be bigger than angle A. But if that happens, what does that tell you? And you have two obtuse angles. Now, I don't know if it's going to work out this way, but I have people that aren't paying attention. Does that make sense what I just said? You sure? Some of you are like, yeah, but you're looking out like the window or whatever. Focus in. Some people aren't paying attention. They're just like, oh, two sides of an angle, there's a match. Oh, yeah, it's SSA. So sine of 121 over 6 equals sine of B over 7. And then they cross multiply. They're still not really thinking about what's going on here. And let me show you what happens. I think this is one that may work this way. I may be wrong, but if it's not, I'll just pretend. No. Why not make it nice? That it. How about, I'll make it work. It's really close. 127. So let's just say you're not paying attention, right? You should just say this: triangle does not exist. It's impossible for B to be bigger than A because B, there's no space for that, right? There's not enough left over. So, but if you would type this in your calculator, guess what you did? And then you go, all right, so angle B is the inverse sine of that. And remember, don't ever round, use the exact answer. Check this out. Inverse sine of the answer. Oh man, look at that. There is an angle B. No, there's not. It's too big. 68 and 127 is already over 180, isn't it? But what if the only thing I asked you about was find angle B? And you're just robotically going through the motions. And now if I had asked you to find angle C after that, you would have caught the mistake probably, right? You would have gone, oh yeah, angle C is 180 minus those two. What? Negative 15-ish or whatever? you would have maybe caught the mistake, but I'm not gonna ask you that because I'm like sadistic and I'm trying to really check your knowledge of this material, right? So I have people every year that just write that, and on something like this, I might give you credit for doing the algebra, but that's a best case scenario. Because I'm trying to see if you know this doesn't work. Now I'm hoping you don't have any work on this problem and it just says triangle B at angle. That's my hope. But are you seeing how sometimes your calculator, now sometimes your calculator is going to say error. Like when it was 121 degrees, it said error. And you would probably go, oh, error, triangle D and E. Great. What do you think I'm going to give you? 127 to see if you're catching your mistake. Are y'all seeing that? Okay, what if I give you something like this? Should you have any concerns about using law of sine here? Why not? Because I already got the biggest angle. What if I have this? Should you have any concerns about finding angles here? Still no. Why? I don't have the biggest angle, but why do I still not have any concerns using law of sines? Because A isn't that angle. A isn't the biggest angle. I still know that, right? Because if B is this, A has to be smaller than B. Are you seeing that? And if law of sines isn't going to lie to me finding B, do I have any worries? I don't have any worries. And then finding angle C, which is the obtuse one, most likely. I mean, it doesn't have to be. It's possible that like A is 55, and then B is like 60, or C is like 65. That's possible. It's still not obtuse. But the point for you is, I don't have any worries because there's no way angle A could be obtuse. The only time I have concerns is if I had something like this. Now, when you go to find angle B, could angle B be obtuse? It could be, because all you know is what? It's bigger than A, so it's bigger than angle A. And because of that, is there a chance bigger than 40 is obtuse? That's the only situation where you truly are worried. All right, now I have a checklist like that. The checklist says, is it SSA? Yes, two sides, an angle, and there's a match. That's an SSA. Is the angle, is this angle acute? These are the checklists on my sheet that I gave you. Yes, it is. Right? Is the side opposite the angle, or the given angle, less than the adjacent side? So is the side opposite that less than the adjacent side? Yes. I used to make people have this checklist, but you don't really need that. As long as you just look and go, all right, I'm looking for this. That's the only option I have. If I'm looking for this, oh crap, B is bigger than A. Angle B is bigger than angle A. Bigger than that, it's possible it's something like 50 or 60, in which case the calculator wouldn't lie. But it is also possible that it's obtuse and my calculator would lie. How am I going to know which one it is? Well, the answer is it's both. And based on those pictures I showed you yesterday, remember? It's possible that this information hits twice or doesn't hit at all. It's also possible it hits once. But do y'all know that there is no triangle in the planet that has whole number angles and whole number sides? Did y'all know that? Like if you think about it, if I have whole number angles, even the nice ones like 30, 60, 90, what were your sides? 1, 2, √3. There's always, or ratios, there's always some irrational term. And if I have stuff like 3, 4, 5, then the angles are like 90 and crazy angle, crazy angle. There's never one. And since I only give whole number values, you're never going to get an angle that's exactly 90. Which means in a situation like this, you're going to have 2 angle B's, 2 angle C's, 2 side C's. And you just have to, and how do you find, you're going to find this one. Your calculator is going to give you an answer. It's going to say error. So if you get one, you get that. How do I find the other one? Subtract it from 180, right? So 180 minus that B1. And at this point, what do? I treat these like 2 separate problems. I go, okay, now that I have this, I ignore that, and I find angle C by subtracting these from 180. And then I find side C using law of sines or cosines. It doesn't matter. Why does it never matter finding a side? Why do I never have to worry finding a side with law of sines? Because what?
Wait.
Even better. You're right, but I could use law of cosines, it's a puppy. But why will... Don't talk like this in college. It's a puppy. Anyway, why do I not have to worry about finding a side? I don't have to inverse sine it, right? When you're finding sides, you're not inverse signing. You only inverse sine when you're trying to find that angle. I'm not finding an angle anymore, and I found this one by subtracting from 180. So you would take these 4 pieces of information, find these 2. And then you're going to go back and then take these 4 pieces of information and find these 2. And that would be the hardest, longest problem on the test, honestly. And if you don't get this one, if this one says error, then what does that mean? Either you made an error, or it's all gone. There's no way. That was the situation where you started like this, and then that third side just never made it back. Does that make sense? My picture of that from yesterday? So anyway, make sure you do all these problems and troubleshoot your work. And if you look at this assignment sheet, I got a quiz over law of sines, cosines, and area we're doing today on Monday. It's just 2 topics. So everything law of sines and cosines, and then can you apply these area formulas? And I'm not going to go through and prove all of these, and maybe if I have time at the end of class, because some of them are really lengthy. But basically, they're all derivations of basic area formulas. But I want to show you the kind of area formulas we have. We did this last year, but like anything last year, you were taking online tests that were open notes. You probably didn't memorize these. You have to have these formulas memorized. So first kind of situation. If you're given side, 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 and I'm finding area on all of these. Okay? Please do not use law of sines and cosines to find all the information and then go try and do a side, side, side every time. You're not going to get finished with this quiz. All right? You need to know that each individual... I had somebody do that one year. They're like, I'm going to memorize one formula, and I'm going to use it for every problem. You're going to spend a lot of time solving triangles. You're not going to get finished. If I have side, 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 you learned this formula in geometry. Y'all remember what it is? Anybody? It is the area is the square root. Let me just write area. A lot of these formulas say K equals for area. I don't know why they use K, but it's the square root of what? S times S minus side A. That's why I don't use A for area, because there's side A, not England. Side A times S minus side B times S minus side C. Now, that formula doesn't mean anything unless I do what? Tell you what S is. And what is S? So, a half of the perimeter. 1/2, so it's a semi-perimeter. So it's 1/2 of A plus B plus C. You have to write that also if you're using the formula, or if I ask you for the formula, or if this part doesn't mean anything. Okay? So if I had a situation like this, A is 2, B is 3, C is 4, I could find, I'll tell you what, I'll make it easy. How about A is, how about this? 10, 11, and 8. So make it 9, it'll make a nice neat whole number. Sorry. Y'all are not erasing my crazy. So, right here, I'm going to first calculate S. So my S is half of the perimeter. So half of 30 is 15. And then all I got to do for area is the square root of S times S minus A, S minus B, S minus C. And then just be careful. So 15 times 5 times 4 times 6. And then you know how to clean up a radical. And if it's a calculator test, which it will be on Monday, and your other test, for that matter, you can just type it in and get a decimal. Now, what would happen right here if C was, be careful, What would happen if C was 22? C, 22. Then you get 10, 20, 30, 43 halves, right? And check it out, 15, sorry, instead of 15, I have 43 halves, 43 halves, 43 halves, and then here 43 halves minus 22. Right? What does that give me? A negative number. So when I multiply all this out in the end, I'm going to end up with a negative number. What does that mean to you? Can't do it. Why did this happen? Because the biggest side can't be longer than the sum of the other two, right? And what kind of triangle does that make when the biggest side is longer than the sum of the other two? It can't connect to make a triangle. So if you caught that ahead of time, I'm like, oh wait, that's impossible. Triangle D and E, you don't even have to do any work. If you don't catch it, you have a second chance of catching it when you see that negative answer there. And we're going to use that for side, side, side. And I have a proof of this. It's like 3 pages. And I normally show people, but I want to make sure we're good with everything today before I show you a proof that you will never remember. I can't literally, I know the proof, and I can't sit up here and do it for you. I don't think I'd remember. I can maybe study and do it, but there's so much involved in it that's really clever algebra. I mean, the guy who came up with that is an algebra freak. I mean, I'll show you if we have time, and it's like, what? It's shockingly creative to get it down to this. I mean, do the math. Just plugging that in there, and there creates a mess, doesn't it? I mean, think about that. If that was in there, and there. So for him to be able to, oh, I'll just call S that and rewrite it like this, it makes it shockingly easy to know. Heron was very great with his algebra skills to be able to come up with that. All right, now that's SSS. What about side angle side? Now again, side angle side is a law of cosine situation, but I'm not finding the other sides. I want a formula that just spits out area if it's a side angle side situation. And remember, side angle side means you have 2 sides, and what angle would go with A and B if it was side angle side? It'd have to be C, wouldn't it? Because remember, there's no matches on side angle sides like there are on side angles, right? Because this would be like side A, side B, and the angle in between them, right? So this is the information I would know. Well, these formulas are pretty easy. Area equals 1/2 product of the sides, sine of C. Every year I have somebody go 1/2 AB cosine of C. Cosine only shows up in law of cosines. Every other formula that has a trig function is going to be sine. So remember that. It only shows up in law of cosines. Don't put it in here. Now this only works with ABC or BCA or ACB. Don't try it with ABB. Every year I have somebody, I'll give them AB, angle B, and they'll try to go side, angle. Can't do it. It doesn't fit in this formula. This is only for side angle side. Right? And of course there's also the 1/2 BC sine A and the 1/2 AC sine B, but again, only these situations. So what would you do if I gave you something like A is 10, B is 21, angle C is 116? Well, plug and show. 1/2, 10, 21, sine of the angle, trust the math. You with me? And that's for side angle side only. So that's 2 formulas. Now the third formula is for what happens when you have angle side, or angle side angle, or anytime you have 2 angles basically and 1 side. Now again, this formula, if you're like, oh, I forgot that formula. Well, if I have 2 angles, I can find the third. True. And you're going to need to do that anyway. And then if I have all 3 angles and a side, then I can just use cosines to find the other side, law of cosines to find the other sides. And then I can use any formula I want. True statement, a lot of extra math. So this situation, when you have 2 given angles, the bottom line is for you, you have to have all 3 angles, no matter what. So, can I find the missing angle? So you have to do one thing manually before you get to the actual problem. So to find angle C, I get what? 72 degrees? And then here's your formula. So the area is 1/2 times the given side squared, and then parentheses, the sine of the two angles that don't match C over the sine of the angle that does match C. So for you, your area would be 1/2, 12 squared, sine of the 21, sine of the 87 over sine of the 72. Plug and show. And feel free to use your calculator button. Your fraction button. Are y'all seeing this? And you might want to practice these. Make sure that you enter them. I know a lot of people set them up and they're like, oh, I know how to use my calculator. And then they get to the test and they butcher everything on their calculator. I'm like, what happened? Well, you didn't get any practice. If you do them, type them in and get your answer and compare it to the key, you're gonna, okay, I know how to use my calculator right. Sometimes that's the biggest problem. And if everybody with me? If you get dotted on everything, you gotta quit with the lock, man.
The lock is draining my energy.
I know, you gotta let it go. I found it in a different part of the room. So it'd be great if you just lock it up and let it go.
The lock isn't, I just
Yeah, you just gotta let it go, man. You can do it.
I have an addiction.
Are y'all with me? So, so make sure you know how to use your calculator. Every year I have one person maybe who gets all the setup great, and then they get the answer wrong, and it's dotted, and they end up getting a 72, 75 on something that they knew all the algebra for. They just didn't have the calculator right. And what mode do we want to be in on these? Gotta be in degrees. Radians, it's gonna think that, if you're in radians, it thinks it's 21 radians. 21 radians is like a whole bunch of spins around the unit circle and then ending here or ending there. You don't want that. All right? Actually, that's not true. 21 radians is like, 1 radian is 3.14, so that's like 1, 2, 3, 4, 5, 6, or whatever. It's just moving crazy. 21 radians is like 6.28 radians is to there, another 6.28 is to there, another 6.28, that gives me close to about 19 radians. Then it ends up being somewhere there, which ironically looks something like 21 degrees, but it won't be, so it'll end up being off. And so be really careful about that, right there. So what have I left off again? I've talked about SSA, I've talked about SAS, I've talked about anytime you have two angles. What's the only one I've left off? I'm sorry, yeah, I talked about SAS, SSS, and this. The one I left off with was SSA. And again, like I always say, it continues to be a pain in the SSA. And we don't have a formula for that at all. So what do you have to do if I start you with SSA? What am I going to have to do if there's no formula? Find more stuff. Now, when you think about the stuff you have to find, let's think about the formulas. Right now, I have this formula for area, and this is for side, angle side. So I have a formula that requires A, B, and angle C. Right? I also have this formula for side, side. And then you tell me what you would use. And that uses S, side A, side B, side C. So again, over here, I've got the A and the B, but I would need this. Here, I've got the A and the B, and I would need that. And you also have a formula for two angles and a side. And that would be, based on what I would do here, I guess I would be using, I guess I could use side B, sine of B, but I'm still missing what? those. So I have this, but I would need those two. Now, what's going to be the easiest formula in general to use, do you think? Just, not in this condition, but in any condition. I think that's probably the easiest one, right? Let's remember. But think about what it would take to find the information you need. Here you need angle C. Here you need side C. Here you need angle C and angle A. So what's the only thing you can find from this information right now? Initially. You'd be finding angle A, right? So finding angle A first puts you not any closer here, not any closer here, a little closer here. But then what am I going to have to find after finding this? From these two, then I would have to find angle C, right? And angle C now puts you here and here, but still not there. So definitely not this one. But my thought is, if you're going to have to find A and C anyway, what would you rather use, this formula or this formula? I'd rather use this one. So for side-side angle, I'm going to use the side angle side formula, but I can't just plug angle B in there, can I? I'm going to have to use law of sines to find A, and then 180 minus B and A to find C. And then I'm going to take C with this A and B and plug it in. Is that making sense? And what happens in this situation? Are you going to have two triangles? Tell me why or why not. I am? I am. Because if B right here is 37 and angle A is bigger than angle B, and you can see that, right? Then it's possible that A is obtuse, which means I'm going to have two angle A's, which means I'm going to have what? Two angle C's, which means I'm going to have two triangles, or possibly what?
No triangles.
No triangles. Now, honestly, I doubt that I'm going to have on your test an SSA with two triangles. I can promise you I will have a problem on your test where you're solving a triangle, and there'll be two. But it's doubtful. I'm not going to say impossible, because it has happened before, but I'm not in the business of trying to let that topic kill you twice. I mean, that just takes a whole letter grade off for that. And granted, that might be worth it because that's a significant topic, but it'll probably not happen. So what I'll probably do is have something like that, and then you'll go, oh, well, A is definitely smaller than B, so A is definitely acute. So in this situation, I'm only going to have one triangle, therefore one angle C. Great.
So, to get no triangles, would you get error from them?
It'll say error on this if there's none. Yeah.
When you find the area, if there's two triangles, which triangle? Do you just find the area of both triangles?
Both.
Okay.
Because remember when I drew that picture yesterday and we swung that arc out, it hit twice?
Mhm.
So there were literally two different areas, one right here and then one like this, that would both have that same information. So you would have to find angle C1, angle C2, plug them both in there and find angle area 1 and angle area 2.
Okay.
And the first one you find is going to be the big angle, right? Because it gives you that, it's going to be the big triangle because it's the small angle C. And then the other one you have will be the really small, tiny triangle that was in there, if that makes any sense based on the picture from yesterday. Y'all remember that picture? The small triangle, and that will be the one from going 180 minus. It will give you the other angle C. But yeah, you would have to give me both. And you'll probably see that in your homework tonight. But on a test, it's probably maybe a 20% chance you'll have one like that where there are two triangles. I don't typically do that, although I have in the past before. So depends on which set of problems I conjure up for this test. Are y'all seeing this? What do you want to see? Anything else before I maybe run through a quick proof or two? Okay, so real quickly, let me just show you some basic proofs of where these formulas come from. Because listen, I'm not gonna lie, like I forget triple angle sine formulas every year. I know how to prove them and create them. So let's just look at a random triangle. And let's just say all I gave you was this angle A. And let's just say all I gave you was this side B and this side C. And those are the only three pieces of information you know. And I said, find area, and you don't know a formula. Well, then you could say this, couldn't you? right? So 1/2 times the base, C, times the height, Well, the height is that. Man, if only there was a way to find that height, given that I know that side and this angle. Oh wait, there is. Regular trig. Isn't the sine of angle A, based on this triangle right here, opposite over hypotenuse? Right? So solving for height, isn't height B sine A? So couldn't I replace height with B sine A? Isn't that my formula? 1/2 BC times the sine of the included angle? Are y'all seeing that? I mean, if you think about it, that worked for this, but I could make that a C and an A and a B and find another one with angle C. Couldn't I? Like for instance, if that's C, and that's B and that's A, then wouldn't I have sine of C equals height over B? And then wouldn't my formula be 1/2 base times height? There's the formula I was going to use for side angle side. Are y'all seeing that? So there's one formula right there. Now, what if I, right here, said, okay, if that's true, that's also true, isn't it? That's just regular law of sines. That's always true. Now, I don't have the information to plug it in there, but, oh, no, that's not true. That's true. All right? Now, let me ask you a question. What if I were to solve for side B right here? Let's cross multiply and solve for B. Don't I get, when I solve for B, don't I get A sine B divided by sine A? What happens if I take this B right here and replace it with that? What do I end up with? 1/2 A squared sine B sine C over sine A. Isn't that my formula that I use when I'm given two angles and a side? These formulas are all linked and related, and they're not super hard to come up with, except for Heron's formula. I got 4 minutes. I'll let you get a glimpse of it, just to be impressed with the algebra. But it's a monster. Maybe I won't. Airplane mode.
The YouTube whole did the YouTube file. This makes no sense. This makes no sense. James, you do this? This makes no sense. They fire him for you, like, okay, come back.
Wait, what did you, wait, let me see it. What was it?
Cora. Bring back Cora. Don't touch her, bring back. After serving like a suspension, they're just like, okay, you're fine, your time's up.
He's gonna return.
All right, I'm not going to be able to,
Not like
in
y'all are
2
gonna be good
minutes,
next
guys,
year.
I can't go through all this, but just to kind of give you a vision of the algebra.
That attitude here.
That's right. He started with a 1/2, or she, I don't even know. That's right. Started with 1/2 base times height. He was given 3 sides, because he's trying to find a formula for something with 3 sides. He labeled height, and then he started going in there and just showing a bunch of Pythagorean theorem. Oh, actually, he said, I'm going to define S as the semi-perimeter. And then he said 2S is A plus B plus C based on that, right? And then he did this series of weird stuff, like he subtracted 2A from both sides, which gave him that when he factored the 2 out, and a negative A. He subtracted 2B from both sides, which gave him that and that. 2c from both sides, which gave him that and that. And then he started doing some Pythagorean theorem stuff with the h and the a and the p and the h and the q and the b. And then he just started doing massive substitutions. Just tons of substitutions. Resolve for p down here. Again, this is not going to make sense.
What year did you do this?
I haven't looked it up. It's been a while. I mean, hundreds of years. He started making all these substitutions, did some clever factoring, and then replacing the p-values from before, which you've clearly forgotten about. I have to. He put those in there, started doing some simplifying, and then did some clever grouping and factoring. You can see this difference of two squares, grouping 3 and 1, like we learned back in Algebra 2, to get it factored as differences of squares. And then he got down to here, and he went back to the original page, and he had already solved for 2 parentheses, s minus a replaced this, 2 parentheses, s minus b, or whatever. He did those substitutions from the first page, there, and there, factored all those 2's out and canceled them with that 4, and then got down to here, used h in that formula right there, cleaned it all out, did some canceling, and drew those first formula too. Shockingly clever algebra. All right, we're ready. Two straight A's. Start. Oh, you already have it down.
Yes, sir.
Well done.
Thank you.
Yeah.